Hello, people. It's very nice to receive us with here, and I call my friends Lilian Carvalho to help us with the English.
For sure, I'll be
So
here helping Thiago.
please help us, please.
No worries. I will be here helping. How many people do we have already in the live stream?
So it's 80 people
Oh my
now.
God, that's a huge cohort, a huge turn up.
So you can present the Hemi for the people, please.
Okay, so do you want me to do in English or in Portuguese?
In English, please.
In English. So Rami is a data science manager, and he's here to talk to us about his expertise with data science, what it takes to be a successful professional in this line of work, right? And Rami, do you want to introduce yourself to the community?
Sure. Hello, everyone. Thank you for joining. Thank you for the invite. I'm happy to be here. It's the first time I'm in a meetup in Brazil, so I'm super excited uh, about being here. I'm a data scientist. Uh, I'm managing a team. I'm mainly using R uh, and other stuff, focusing on time series analysis and forecasting. Recent years, I also so I there are some, data science is a very wide topic, and under this, there are the stuff that professionally I learn over the years, like time series analysis, forecasting, data visualization. There are other stuff that I enjoy doing because working with data could be fun, like doing maps. And I think in the last 2 years, I also enter into production. So how to take your stuff into production, and that's kind of like the focus of today's uh, meetup. That's what I'm going to present today.
Ok. Você quer que eu traduza, Thiago?
Por favor.
O Rami falou que ele trabalha na área de produção, né? E que ele usa mais o R como linguagem de programação, e agora ele está entrando mais em deixar os modelos dele, trabalha com previsão, né? E séries temporais são os testes que ele mais faz, e agora ele está botando esses modelos que ele tem em produção, tá? É isso.
Very nice. So would you like to share with us your slides?
Yeah.
Feel
So
free to it.
I prepare some slides, and we can go over the slides, and then we can leave some time for Q&A if it's okay.
Yeah,
Okay.
sure, Rami.
So the only thing that during the slides, I cannot see the screen because I have one screen. So if there are, maybe we can, every few slides, we can stop and see if there are any questions. And then
if there are any important questions, Thiago and I will open the
Chime
mic
in.
and ask you,
Yeah.
interrupt you, okay?
All right, perfect. So
In
let
real
me
time.
try to share here.
Okay.
Share screen.
We already see.
Okay. Can you just give me a signal if you can see my screen, my presentation?
Yeah, we can see everything is fine. You can start.
All right. So let's kick it off. So today, as I mentioned before, we're going to talk about production, and more specific about deploying machine learning models into production environment with the use of open source and free tools. The talk is focused on mainly in R as the language, Docker as the tool to create the environment, and GitHub as the process to make deployment. But it's not you don't need to know those tools to understand the concept. It's more about conceptually how to do it. You can deploy the same thing with Python, Julia, or any other language. And there are other tools, so it's not necessarily the only way to do it. But I think what I want people to take from this conversation, that it is, as a data scientist, it's good to know how to take your work to production. And it's a good skills to have. So with that, I will start. So I already provide some introduction, but this kind of like summarize who I am. On the right side, I'm R person. I mainly use R, doing a lot of time series analysis. I'm author of several R packages, and I wrote a book about time series analysis with R. Last but not least, I consider myself as a mediocre DevOps and data engineer, and I think that's what you need as a data scientist to be, to take your stuff into production. You don't need to be, a super DevOps or data engineers. You can learn the basics, and it's enough at least to begin with it. So just kind of like to set the expectation. So, the agenda for today, we're going to talk about a little bit why we want to take our work into production. We're going to talk about some project that I did as an example to deployment of a machine learning model. So we're going to talk about the architect, the tools, and then if there are going to be any questions at the end, we definitely can have a Q&A. So let's talk about general project workflow of a data science. So typically, you start with a business problem. For example, how many units we're going to sell, what is going to be our customer churn or capacity planning. And as a data scientist, you will probably use something like R or Python, or could be other languages. And once you understand the business problem, you're going to look for the data that it requires to solve this problem. And then typically you will go to some APIs, database, or any other form of data, conduct some data transformation. And then this is where the really fun start, when you're starting to explore the data, do descriptive analysis, visualize, doing some summary statistic, hypothesis testing, understand what's going on in the data. And in some cases, the next step would be take the knowledge that you acquired in a descriptive analysis and apply it in a predictive analysis building model. So here you're going to use some modeling, either statistic, machine learning, or anything similar. You train models, evaluate your performance, and once you're happy about the approach, you go and you want to communicate the results, build some dashboard, reports, API, and so on. And I put here a lot of symbols of tools that I typically use, but not necessarily limited for those, of course. Last but not least, you want to deploy your work into production. This is how I think you get the visibility about your work. If you are creating something but you're not communicate and put it in production, you get less visibility or acknowledge about your work. So I think going into production is very important. And here you will use some CI/CD tools, automation, and other.
Great. Rami, do you use Plumber to create APIs?
Yeah. Plumber is one of my favorite tools. Yeah, it's great. It's amazing how great it is to make it simple to create API. Typically 70% of the time we will spend about understanding the business problem and finding the data, and 30% of the time we'll spend on the rest. The modeling part is typically very simple. Like what typically, and probably I won't surprise anyone, that what is challenging is to get the data and organize it, and it's really derived from defining the business problem. In ideal world, you will have a business analyst that define the business problem. Then you in your team should have like a data engineer that will help you to pull the data. And as data scientist, you will do the descriptive, predictive analysis, and the visualization to communicate. And then you end off to a DevOps team. In reality, if you are in a small team or a small company, not necessarily that you will have, you won't be necessarily fortunate to have a data engineers and DevOps team. And this is where, and you might have a business analyst or not, but this is where the terms full stack data scientist came from, where you're responsible from essentially getting the data until the end of the project, with putting your product in production. And I think most of in the life cycle of a data scientist, typically we start with the understand what is descriptive analysis, how to build models. But when we get to the first job, if most of us are understanding that it's more than just building machine learning models. If you're not able to nail down the data and then down the road when you're getting to the end of the project to deploy it, kind of like missing the the point of building a product.
So great advice.
And if someone would come to me a couple of years ago, and if I had to give to myself an advice, where should I invest my time, I would tell myself, put time in learning automation and productions tools. The value, is incredible. Like when you can take your project into production, it's the joy is, I cannot describe the joy. It's also like, as a data scientist, I think job market value people that can take their work into production, give a higher value than just being modeler. And always the example that I can think about, like if someone will come to me and say, hey, I can build a crazy deep learning models to predict something, and using cutting edge technology, I would say that this is awesome. But if someone will come to me and say, hey, I can build a linear regression and deploy it in production, I will tell this person, you're a god. Having the skills is, I found it much more valuable than just deploying crazy models. So let's talk about productionize open source project, or what was the motivation? How did I come with this thing about doing stuff with open source? So it all started when the pandemic started, and I started to work, it was really February 2020, when the COVID-19 pandemic was at that time called it was named as coronavirus. So I created a package under the name that it was at that time, coronavirus. And I started to collect the data from the Johns Hopkins repository. And I found myself at the beginning, I didn't realize that it's going to be something going to stay so long. We are, almost 2 years after, and we're still here, unfortunately. And, every night it was something new. It was then really only in China, but, as time passed, it started to spread to the rest of the world. And I found myself every night trying to catch up with automated data, refresh the data. And at a certain point, I realized I cannot continue to do it. I need to find something much more efficient than
It's a hard job, yeah.
What?
It's a hard job, yeah.
Yeah. And, it's not efficient also. So this is where I started to adopt, tools like Docker and GitHub Actions. to start to automate the process. And this is now, I think, every R package that I'm creating, by default, I have a Docker folder that I'm, creating an environment for Docker and using GitHub Action. And I also add like a CSV folder that I'm running a job, automate it, and dump it in the CSV folder. And the output was I was able also to take it further and create a dashboard. And for those of you using R, I use Flex Dashboard.
Great package.
It's an amazing
I
package.
love it.
And it technically, for I know how much people familiar with R, but it's enable you to take a it's based on R Markdown, which is enable you to create documentation, and this package enable you to create dashboard, static dashboard, render it into HTML, and you can deploy it in any website. So if you want to, for example, take you have some data and it's getting updated and you want to display it in somewhere, it's easy to do it with GitHub Action and Flex Dashboard. And I will show later on kind of like how you can do it or where you can start with. And this is the example that we're going to talk about today. So after I created the automation of the data for the coronavirus, and I created a dashboard that gets refreshed every day and show the most recent data. Say, okay, so why don't we show how, it's very easy to use it. It was, once you understand the concept, it was straightforward to create it and use it. So let's just create an example about how you can actually leverage it to deploy a machine learning model. So I suspect that it might be a bit more challenging to build it, but I said like, okay, let's give it a try. And I decided to take this data of the total demand for electricity and create a forecast and do the automation. So it's running a machine learning model to create the forecast and then display it in a dashboard. So let's pause and talk a little bit about this dashboard. What is this dashboard provide? So it's also based on the Flex Dashboard package. The visualization based on the Plotly package. It's a static dashboard, meaning that once it rendered, it's HTML. So you cannot change it, like, for example, Shiny. So it doesn't require a server. And the dashboard refreshed and render every hour. So the data get refreshed every hour. So every hour you can get refresh and get the, compare the forecast to the actual and deploy it on GitHub Pages. So maybe I will pause and explain what is GitHub Pages. GitHub Pages is a tool on any repository that enable you to create a website, to deploy. It was designed to deploy the documentation of the repository. So for example, if you're using R package or Python library, when you're going to the documentation, typically you will see that the website is something with GitHub, and it's essentially deployed with the GitHub Pages. And then so the point here was not about the forecasting, but show taking a machine learning model and deploy it in production, and just to demonstrate how simple it is to do it. So I use the H2O package, which is a great package for machine learning applications. There is R and Python version. Specifically, I used ElasticNet, which is a combination of a ridge and lasso regression. Typically, I prefer to use more simplistic models for forecasting. The only motivation to use something like ElasticNet in this case was that it's hourly data, and I created a lot of features, and I wanted to have some regularization, let the model to select the features that are working best in the for the prediction. So in this case, ElasticNet is a bit more robust compared to a simple linear regression. And so I used the features. So I created features, seasonal trend, legs, and other features, and throw it into a model. I trained the model. I use a back testing, which is, I know if folks familiar with this term, but back testing is the time series equivalent for the machine learning cross-validation training approach. So essentially, you are dividing your training data into multiple testing and training and testing partitions. You are train your models on each training partition and evaluate on the corresponding testing partition, and then you can understand how well the model is performed. The only difference between backtesting and cross-validation is that backtesting is for time series and the data is sequential. So you cannot randomly sample it. And the model provides a 72 hours forecast ahead. And once the time that you get to the end of your actuals refreshed and you're having all your forecast point realized with the actuals, it automatically will generate the next 72 hours forecast. So all those things are automated. And again, we can continue to talk about machine learning, how fun it is, but that's not the point. And at a certain point, it's becoming really boring. So let's move to the real stuff, which is the architect behind of those model, this deployment. So this is a simple schema of the process. So we start with the GitHub Action. Is the scheduler. Essentially what it does, it's trigger a machine. You're saying, I want to run some script every, let's say, every 6 hours. In this case, it's running every 1 hour. So you're setting a cron job, and this cron job triggers some virtual machine that runs some code. That's it. That's the only functionality. But it's essential. Without this, you cannot run the whole process. The second component is the environment. There are multiple ways to set environment. Essentially, anytime that you're triggering a machine in GitHub Action, you're getting a clean machine. So you can go and run multiple steps and start to install all the dependencies. For example, I'm using R, I'm using H2O, I'm using JQ and other command line tools. Or you can just set a Docker, and each time just point to this Docker where all the environment components is set over there. Maybe I didn't explain what is Docker, so I just will talk for a second about Docker because I think it's important to understand what is Docker and what is the use of Docker here. So Docker, if it's one of the things that in my data science career I can divide it before I knew Docker and after I knew Docker. It's a magic tool, and essentially Docker enable you to create something like, if I need to use like a really simple word, it's enable you to create a virtual environment that you can reproduce your work in multiple instance.
Totally
So you create
reproducible, yeah.
Yeah, it enable you to do reproducibility in the high level of, in my mind, it's the high level of reproducibility. So I can give an example. So for example, I can, if you can see, this is a Raspberry Pi, and let's say it's a Linux box. What it does is essentially you are installing your machine on some Linux box, you're installing all the version of the packages, and you can test it, and I can virtually give it to any one of you. And if you run the same code that I'm running on my Docker image, you will get exact same result. And why?
Amazing.
The reason that this is a great tool, it solves a lot of problems in production. So typically, before there was Docker or anything similar to Docker, you would have the backend team that develop the stuff, and you have the people that deploy the product into production. So think about like if I'm the developer, and Diego, you are the DevOps. If I'm installing version R 3.5 and I'm using dplyr version 8085, and I know I'm running it on Linux, and you are using Windows, and you have version 4.1 of R, and dplyr 1.105 or anything new, and I'm running some stuff and it's working on my end, but then I'm giving you the code and it starts to fail on your end. Now go figure out if it is because you are using a different OS or a different version of dplyr or different version of R or anything else that could go wrong in the process. And this is what Docker enable you to avoid. You are creating a virtual image, which is it's not a virtual machine, but it's like a virtual machine that enable you to shift it with your code and just as is, the reason that there are containers, like container, you move it from one place, put it in another place, it will still work. So that's Docker. Highly recommend go learn Docker. Like if you're not familiar with Docker, it's something that's worth to learn, no matter what stage you are in data science, or if you're doing any similar work that involve in reproducibility, go learn Docker, please. It's amazing. And then in this process, so I'm calling GitHub Action, I'm setting the environment Docker, and then R is the main driver here. So R trigger H2O. There is a bash script that I'm using to trigger the R script.
Rami,
The trigger.
Vladimir said, I have been using Docker to configure virtual environments in my NVIDIA Jetson Nano for embedded AI projects in production, and it's real lifesaver.
Yeah, I mean, I cannot think about myself going to a project without Docker. Like my R package is my personal project. I'm talking now all about personal project. It's like by default, when I'm creating a project, I'm starting with Docker. That's kind of like my approach for anything, because that's the best way to reproduce. And then like when down the road, I mean, if you want to deploy it somewhere, it's like make your life easier. So I'm using bash to trigger the script, and I'm pulling the data. So the modeling component is H2O, as I mentioned. The visualization component is with Plotly and R Markdown to create the dashboard. And once this process running, it's go into it's render it into HTML file, and then it deploy it into the GitHub pages, and then you can anyone can go to the link and get access for it. That is as it might sound complex, but if you take those multiple steps and go step by step, it's actually very simple. So this is an example of how you set a GitHub action. So it's a YAML file that's technically it's the manifest of what you want to run. It's what I call the when, where, and what. So you start with when do you want to run it. In this case, you see I'm setting a schedule. I'm setting a cron job, and this is like how you set a cron job. There are five fields. Like each one is this, those stars, and it represent. If I start from left to right, is the minute, the hour, the day, the month, and the day in the week. So, for example, if you want to run every midnight, so you need to set 0, 0, and star. So, just saying every day at the 0 minute of the midnight, run this job. And if you want to, for example, run the job every first day of the month, so you're just setting the third symbol as 1, or the date that you want to run it. But it's straightforward. There is the cron tab guru. It's a website that you can explain like how to set it, and you can say it's translate. Like, for example, you can see that I put here 0 and then star / and 1, and it's just saying at minute 0 past every hour. So in simple word, every hour run this job. And so where here is like where you want to run it. So because I'm using Docker, and my Docker is based on Ubuntu, so I'm asking from GitHub Action, give me Ubuntu machine. And then I'm pulling this image. And just, on the right side, you can see like how I'm building this image. So I have a bash script that, doing the build. So you can see that the Docker build.-t and on the middle box is calling the one on the right box. We're just saying, it's pulling version, another Docker with already installed version 4 of R, and it's calling another script that install all the requirement packages. So you can see that this script is saying you're starting, always think about like when you're starting in a new Docker, you're starting with a clean machine. It's like you bought a machine and you open it from the box. And then you need to install all the stuff. Now, in this case, I'm pulling a built-in Docker with all the prerequisite, but you can start from scratch. Or you can have like, other people building Docker. In our community, the most common one is Rocker, Rocker, I think it's the name. If I'm not, I think it's Rocker. It's a bunch of Dockers that pre-configure with a different version of R and different common packages like tidyverse packages and so on. So essentially what I'm doing here is like I'm pulling this Docker and then I have all the packages that I need to run my script. And this is important because if you're not setting your environment properly, your code will fail. So far, what I did here is just set a cron job and then trigger the environment. And then the next step is to take the main branch. This is the branch that I have the code, and run this code. And here I have this bash script, and I'm pulling the API key to pull the data. So it's stored in a secret. You don't want to expose your API key, so I'm using secret here. And I'm calling R script that pulling the data and running all the process. So it's going check if new data is available, and if it does, so it's pull the data, and it check if the forecast finished the cycle, like if you have all the data point that you forecast, and if yes, it trigger a new forecast, and if not, you just refresh the data and render the dashboard and push it back. So that's the whole story. This is how simple GitHub Action. And before we jump to see the dashboard, this is the source of the data. So I use one of my favorite data sources, which is EIA website, which is a energy information administrator, which is provide a lot of data about energy in the US. In this case, it is the US demand for electricity, but you have the consumption of gas, oil, gas and oil or other energy sources prices, and so on. If you like time series data, I recommend you to check this website. And they provide the API, so it makes the whole process easy. I have my API key, I'm hitting the API, I'm pulling the data and refresh the dashboard. So this is one of many projects that I'm doing in parallel. So it's kind of like, for a while it's been work in progress. I have a board with list of items that I need to clean up from my table to continue this project. This is kind of like the roadmap. I want to add, so this is, the reason that I build it, I want to help other people to understand how to build those stuff. So I think like, the last point here is the documentation, is building the documentation that people can go and be able to take their problem using their data and apply it to the same process. So I think that's kind of like, what the end goal here. Other component that I really want to add is be functional, meaning create a JSON file with all the setting, and for example, enable people to fork the dashboard. Now it's set for pulling specific series from the API. But for example, if you change the code of the series from the US total to California total, you will essentially, by changing this, you will get the total consumption, a dashboard for California or Texas or New York or any other series that's available. And I think I should improve the data visualization. I built something simplistic. It was just to showcase. But I think, can do more better on that front. So there are here some resources that for what I used. So first, the dashboard, I will go in a second, is available on my GitHub account and the code as well. Docker. So if you are not familiar with Docker, go to docker.com. There are great resources in YouTube to learn Docker. If someone need, I can reference for those, but it's it's like if you search on YouTube Docker tutorial, you probably will find on the top the best one. And there is the EIA API, which is a great resource for if you like to work with time series data. So it's fun API to work with. So before we go into question, I just jump to show.
Great, thank you very much. So it's very, very useful, to make the environment reproducible, In research, it's very necessary, And the employee, the companies use too much, It's very nice. So we have
just before we
question,
maybe before we jump for questions, like just show you the dashboard. So this is the dashboard, and actually, I probably, let's see if I refresh it. Yeah. So last time that it was refreshed was so now it is 6 o'clock Eastern time. So it's literally refreshed a couple of minutes ago, and you see that the solid line is the actuals. The dashed line is the forecast, and sometime tonight when it get to this point, it will trigger a new forecast and provide the next 72 hours, and that's the cycle. So it's provide it's refreshed every hour, check, update the new data point, refresh the forecast whenever it's reached to the end of the forecast cycle, and also provide, so this is the demand, and this is the generation, the energy source that used for the generation. And code, so this is my GitHub page, and you can go over here under US electricity, and all the code is available here. So this is the actions. So you can see it's run every hour, and you get the green check mark, which is just saying that it was successful. It sends email whenever it failed, and sometimes it failed because system issue or something like this. And then you can go and see how the code ran. So for example, you can see the data refresh, and it's going. You see this is the combination of the R code, the trigger, the data pool, and so one thing that I usually do when I'm thinking about this type of deployment, I'm creating messages on each step. I typically use colors also, and I make sure that if there are some errors, so I get a red color, and if it's good, so it's green. So it's easy if something happened and you want to debug. It's also something you need to think about, like how to read your code and to debug. And this is like the next step is rendering and pushing the data. So I will pause over here and see if there are any questions that I can answer.
Amazing. Thank you very much.
Yeah, thank you, Rami.
You're welcome.
So we have questions, people. So before we have the questions, I've forgot to present the the professor Lily. Sorry. So she's PhD in marketing from Sao Paulo Business School, FGV-EAESP, selected by NASA as data science for the Datanauts program for the fall 2018 term. Director of the Digital Marketing Lab at SPFGV, and worked as visiting researching at John Molson School Business, Concordia University, Montreal, visiting lecturer at Our Business School, UK, co-author of the book Basic in Business, having sold more than 120 copies of her book.
Yeah. There is a question. Thanks, Thiago.
So thank you very much to help
No
us.
worries.
Yeah,
No
you
worries.
have a class now? Yeah.
In roughly 10 minutes, I will leave in 10
Oh,
minutes, but I
okay,
can
okay.
ask a little bit of, because there is a question from Vladimir. Vladimir is asking, Rami, what should be the ideal balance between exploratory data analysis and model deployment skills for a data science? Something like 70-30?
That's a good question. So
Great.
I think that you should start definitely with the exploratory data analysis skills, build those, and the modeling component, the predictive. And once you reach to a certain point that you feel comfortable, you should allocate more time to also learn. It's a hard, I always find there are so many things that I'm trying to learn that are just limited by time. So I think, if you're, if you started your journey, invest the time first to learn the what the backend that you need to become a data scientist. And if you have more time, definitely invest in. It's amazingly like the easy to learn. It's not that complicated. You just need to have some basic knowledge in command line, but then like jumping and learning like Docker, it's straightforward, or GitHub Action, it's also easy. So it's there is a trade-off, but I think once you have a solid background, and typically people start to learn it when they get stuck in their work and they need to deploy something and nobody can help them, and this is where you sit and you learn it. So ideally, if you can learn it before, it's great, but 70-30 probably a good ratio.
Oh, great. I will make a question. So in the companies of that you have worked, they had all of them had machine learning engineer or not?
No, I think a couple of
It's
years
common.
ago, when maybe today it's much more trivial to have, but still I feel like even in the big companies, if you are joining to a small team, not necessarily that the small team will have all the data engineering and the DevOps and all those components. If you joining to a big team, in some teams like already savvy and robust, and they might have it, so you're fortunate because you can see and learn from others. And if not, you will have to learn it by yourself, and it's also fine, right? I think part of my journey is like when I realized that, along with my colleagues, that we need to deploy it in production, and that's how we learn. And also, that's what's nice about being open source contributor. That's some of the stuff that I learn on my work for my open source project, I also take it and apply it in my day-to-day work. So it's kind of like a good relationship, about knowledge, learning from both, personal
It
project and
depends
also,
on, yeah.
yeah.
Okay, very nice. So Eric Araújo, I loved its simple yet detailed presentation.
Thank you.
Thanks, Hemi. Come back often. So come back when do you want? Yeah, it's your home. Yeah, it's a really pleasure have you with us. Yeah. So we
Thanks.
have more questions. So
I don't think so.
So Vladimir said, "Thank you very much. Real insightful presentation. Yeah,
Thank you.
it's show that the role power of your area. So to make data analysis, to make forecast, yeah, to put in production. Many people that don't know too much are think that you can't put on production. Yeah, it's it's
Don't go there.
unhappily
That's like 5 years
unhappily it's
ago.
a large people that I know. Yeah, and so it's a great contribution. Yeah,
Yeah.
thank you very much, and we will have. We will make a certification, yeah, with 5 stars for you, yeah.
Yeah.
And we will
Today
send to you.
taking R to production is straightforward. It's not about R. It's like you're using other tools to put it in production, and R also, there are many tools like you mentioned the Plumber API, right? It's a great tool. There is RStudio Connect that make your life easier if you are in enterprise world. And yeah, so today, you're leveraging ecosystem to check your code, and it's not necessarily related to the language they're using. It's more like the setting the Docker is important, and having the infrastructures is important. If you set this, you can run any code, anything. It's irrelevant to the language. It's those tools make the ability to production in any language. So definitely R can go to
the R
production.
have reticulate, and Python have RPy, so you can enjoy whatever the language, it doesn't matter, Very, very nice. So, who wants the certification? It's not a 5-star like the Rami, but we will receive either. So you can preencher, como é que é? Fill the certification, and we'll receive the certificate either of this awesome live. And thank you very much, Rami. Welcome back when do you want. Okay?
Yeah.
Thank you very much.
We're happy to come. We talked before. We're happy to come visit Brazil. It's like
when you come,
very nice.
Send us a message.
Both Rio and Sao Paulo.
Thiago. Thank you, Rami. Thank you, Thiago.
Thank you all.
Bye.
Bye, professora. Obrigado.
Bye.
Opa. Bye, Rami. Bye, pessoal. Valeu. Tchau. See you all.